In this video, we're going to be taking a look at one of the ways that we can calculate the free energy change associated with a reaction. Under standard conditions, 1 atmosphere, 298 Kelvin, 1 molar concentration, the delta G for an overall reaction may be calculated from delta G of formation values, just like we've seen before for delta H or delta S. This is because of Hess's law. As a reminder, the way we do that is the delta G of reaction will equal the sum of the delta Gs of the products minus the sum of the delta Gs of the reactants. A couple helpful tips. You can only use this method under standard conditions. Otherwise, you have to use delta G equals delta H minus T delta S. And I have another video up on how to do that type of problem. Secondly, you have to make sure that your free energies of formation values are for the correct indicator of state. So make sure that you're verifying, is this a solid, is this a liquid, is this a gas, or is this aqueous? Because all of those values are available to you in reference materials. Let's take a look at an example. We're going to calculate delta G reaction for the smelting of iron. Fe2O3 solid plus 3CO gas becomes 2Fe solid plus 3CO2 gas. And I will pause here for a second, give you a chance to try it on your own if you wish. You can find values for these delta H or delta G formations in the back of your textbook. And here are those delta G of formation values that you need. These are very specifically for these substances with this indicator of state. One in particular to note is the solid iron. Pure elements in their native states will have a delta G of formation of 0, just like they do a delta H of formation of 0. Let's plug in our numbers. Delta G reaction is going to equal 2 times 0.0 plus 3 times negative 394.4 minus, again in parentheses, minus 742.2 plus 3 times negative 137.2. As we crunch our numbers, we're going to want to be very careful of not losing negative signs. And here's what that number crunching looks like. As you break it down, our final step will be a minus 1183 plus 1153.8, giving us a final answer of minus 29 kilojoules. Two things to note. The per mole part of the unit drops out because we multiply these delta G's of formation values by the stoichiometric coefficients from the chemical equation. Remember that those say 1 mole of iron oxide to 3 moles carbon monoxide, so multiplying by those coefficients is multiplying by moles. Moles cancel out. This process is also very slightly spontaneous under standard conditions. So there you go. Here's how we can use Hess's law with standard free energies of formation to calculate a delta G reaction. For the other way of doing it through the Gibbs equation, please check out my other videos. See you in class.